I'm Sean. I work now with TDB Consultants. I process raw LiDAR and photogrammetry. So my world's a lot different from the cartographic world. It's really cool being here and seeing what can be done. Right? I mainly just specialize in acquisition and raw processing. And honestly, this project isn't much different. It's pretty cool, pretty interesting, but it's small and humble in its own way. And you see these presentations, and I'm curious what other people here who do these major analysis. My analyses are more about, matter of millimeters or centimeters or accuracies. But some of the data that could possibly be generated, what you guys could do with it. So that's a candidate for the longest title. I'm not sure, but here we go, actually. So after logging is completed, we have cut blocks, we have logging. We end up with things like these. Usually, those are just some examples we've taken recently, but often it's still good wood. It's just not economically feasible for the logging companies to put trucks out there, back out there, and then bring it back in. It might be $100 to process and bring back something that they could get $50 for. So what happens is we have scalers or independent auditors who go and they measure certain aspects of these piles. They'll do quality wood, they'll do things like what could have been avoided, what was just natural, and they'll assess it. But one of the main things we're concerned about is they actually take measurements of each pile. And unfortunately, it's such a complex shape that all they do is basically take a sample and they do the length times the width. What we're trying to do here is find something a little more robust, a little stronger that can be done to measure these piles. Forestry waste is a prominent contentious issue. I'm not an expert on it. I'm not going to go too much into it. There's very complex things, and people here know a lot more about it than I do. So despite, there's environmental concerns. Often if the piles, they find that they're not worth taking back, they'll burn them or just leave them there. But also overestimated waste volumes result in unfair increased fines to the licensee, and underestimated because the Crown gets charges stumpage fees for what they calculate. They'll get money back because it's wasted. Licensees demonstrated that the costs of conducting waste surveys often outweigh the revenue associated with waste billing. It's particularly evident in the interior where waste volumes are near the benchmark volumes and stumpage is low. It would be beneficial if more cost-effective way of establishing a reasonable estimate of waste was developed. So we look at this, and it's just a project we look at now and then. And can we do something with remote sensing? So here's just a quick video. So getting the data. This has to be cheap. We can't just get the best things possible and fly it all over and get all multi-sets, like do data fusion with LiDAR and photogrammetry and satellite work. And so it has to be pretty cheap. So some of the things that we would do here, we would look at are airborne photogrammetry with a large format camera and direct georeferencing using IMU on it. Airborne LiDAR. UAVs, drones are RPAS. And look, the research has been into stereo imagery. It's possible, but that's kind of, we can touch on that later. When we look at photogrammetry versus LiDAR, one of the main advantages of LiDAR is you get more penetration in the canopy of things like that. But when we're modeling these, we turn these point clouds that we derive into 2.5D rasters. We turn them into DSMs. That's what we do. We end up with cut fill for our measurements. So LiDAR is great. That's what I do. I'm much more comfortable with it. I spend all day in Terrascan just looking at point clouds and things like that. But I had some data sets where I was able to derive point clouds and compare to LiDAR, and once they were modeled, they were pretty much the same. Slight differences. but LiDAR to process is generally much more expensive. Photogrammetry is generally cheaper and easier to process, requires less specialized equipment training. High-res imagery helps a great deal in manual detection, and it's necessary for many online classification processes. So here's me with my Phantom 3 that's not working, and I crashed it and all that. But for small areas, I mean, UAVs, drones, it's feasible, but we haven't had any luck with it. It's just not working that great. RTK communicates sometimes. If not, you're setting up geometry with your aerial targets, and you may as well just walk around these things instead of doing ocular assessments. Some of these areas are so remote and they're so hard to just walk across that it's not really worth it. We rarely need, I mean, we don't need a 3 centimeter resolution or anything like 10 centimeters seem fine. And also we have all the government requirements, SFOCs, things like that. Just comparing something like, so an Ultracam Eagle Mark III, which Kisik down in Vancouver uses, I mean, in one shot you can get 2.6 kilometers wide, and you can just get crazy overlap. I mean, they advertise 94% forward lap at 250 kph, but I mean, you wouldn't do that. You'd be doing more like 80. Or SenseFly EB, which is kind of better for these open fields. It's, you know, it's great for what it is. I've used it before, but it can only go up for 50 minutes, and you can't, I mean, you just get a special license so you can fly it at 10 centimeter GSD. So this is another project that we kind of looked at within the Williams Lake TSA, where we estimated that these blocks here we could do within about 2 days of flying. So it's about 80 to 100 blocks with optimal conditions. And you think, I mean, pricing that out, that might be $25,000 to $30,000 when you divide it by each of those. It might end up being, say, $300 to $350 for the acquisition. Once we have that, I mean, that acquisition is only half the battle. We have to process them. And we have to create surface models and rectified imagery to create polygons around the identified waste piles and calculate volumes using GIS cut-fill tools, something like Global Mapper or Pix4D. Terra Modeler is good. Those are the things that I've been looking at. So once we process, here's something in the Anzac region north, much, you know, around Mackenzie. So there's just a simple orthophoto. Some of these things are quite easy to process with monophotogrammetric methods. You can batch script them and just have that in a couple days. You could do all those areas. Here's just a quick photogrammetrically derived point cloud. It's kind of a low resolution. But you can see those are the things that we're trying to measure. So we convert to this. And well, everyone's seen one of these, surface model. It's a GeoTIFF or .dem. And so our quest is to, for all of these, draw little tiny polygons as tight as we can around the borders of each one. So if we're doing that at scale, it's the only way this really works. If we do it at scale, we might have thousands of these. It might be hundreds of man-hours. So remote sensing, we try to, I mean, we're lazy. We don't go outside. We look at satellites instead. We, or photos. So we try to get the computer to do the work. So some of the things we've looked at are like manual delineation, which take a long time. OBIA, which is what I always go to first if I'm doing any sort of high-res imagery classification work. And pixel-based classification, just traditional stuff. This is complicated by the fact that it's such high resolution and it's such a messy area. Right? So we share many of the same spectral characteristics as surrounding features. I mean, it's even hard to tell the wood pile when we're zoomed up on them compared to what else is out there. I mean, like that's actually not one, but that's one and that's one. And you can see that it has the same linear features. It has green, it has brown, it has all the logs and everything. And there's a lot of them. There are other height variations. So when we're classifying these things, we want, just as a very broad example, we want brown classes, everything that's brown, to be in the brown class, and we don't want anything that's green to be in the brown class, right? So it gets pretty difficult. So with OBIA Object Analyst, we can incorporate other data dimensions into the classifications, not just the RGB. We can use various vegetation indices and elevation models in order to help to increase the separability between the classes. We also are able to use image segmentation to delineate shapes. So here we see that all the logs are highlighted that within this little area that they actually have their own generated polygon. I found that it was easier to pull out surface information, all the features of all the logs on the ground, all the logs on the piles compared to the piles themselves, which are a homogeneous mass of other spectral elements. So here we have, I take the RGB data, here's an elevation raster I made. So these polygons are hard to differentiate between the ground, so I'm able to bring this in to differentiate from the ground, but then it's hard to differentiate from the tree. So then I just make a greenness index so it can differentiate the piles from the trees now. I mean, does it work? Sometimes. We often have like piles of dirt around. That's going to show up when we incorporate elevation models. They're going to have logs and greenery and residue. And that is something I found out. I mean, you might come up across any sort of weird thing. So usually we manually identify them after they've been classified, just to make sure. So we end up, because no matter what we do, and no matter how careful our classification is, we still get all these tiny little things. So this is me trying to find polygons in this small area. But we also can incorporate rules, spatial rules, into our classification. So I just, since it's easy to actually find them, I looked at the smallest polygon that we wanted to keep, and then I took out everything under 16 square meters, right? So they ended up with that, just as a small case study, and there was just one false positive here, which was kind of a mound of dirt that we saw before. So we made a map, we sent it out there for the guys to check out. And I mean, one of the purposes of this project is, could we even see these piles? Could we even measure them or do any sort of thing? And so the guys came back, and so we found 94.3 of the piles in the study area, but what we didn't measure were some of the cold decks, which might be something that we could work on. Now, the way they measure it and the way we measure it are completely different. I mean, it's not quite apples to oranges, but it's kind of apples to apples from some other planet, right? So they're only in 2D space. So they're coming back with something like 468 square meters, where we draw this complex polygon, and it just, and it figures it out for us, and we're getting something like 691 square meters. And then we're able to get an uncorrected volume of 842 and change. The uncorrected volume is because there's kind of air gaps in the piles. They'll do correction factors, right? So 33% difference in area. When we look just in 2D, I mean, some of them are bang on. Like that's what they came back with, and that's what I came with. It was, it was stupendous. But then this one, right? We had over twice the size in area. So just some next steps. We need more data. What I would really like to do is, I'm supposed to get out there this summer and do some more field work with these guys. I would like to get some really strong spatial models of these piles by using close range photogrammetry in total stations, setting up reflector targets, flying around with a drone possibly, but also just getting in there with a consumer grade camera and building a point cloud and referencing it in like Cloud Compare and building a mesh and really getting it going. Keep refining the classification models, including the incorporation of neural nets and deep learning. That's something we've been looking at as well. And research any new avenues that may present itself and streamline processes in order to reduce costs. We need these as cheap as possible to make it effective. And that's it.